Without further ado, let's welcome our next speaker, and that's DC, who's a co-founder of Daimo, and we're going to talk about L2 intent addresses, and it's a new way to think about how to make payments across different networks. So please give DC a big round of applause.
All right, perfect. Welcome, everyone. Hope everyone had a good dinner. Perfect. Oh, all right. It's on either side of me. That works. That's great. We're going to talk today about a new primitive that we've been working on and share some of what we've been cooking. And it's something that we're pretty excited about because I think that it lets you do some really nice user experiences on Ethereum, right? Like a lot of things about the underlying technology have just gotten enormously better. We have 1 cent, 1 second transactions now. If any of you were like at Liam's talk yesterday, you saw him talking about like stablecoin proliferation. There's amazing things happening there. But the actual user experience is still not so great. Let's take a look at that. So we're going to talk about what's the problem. We're going to talk about some of the sort of prior work that inspired what were intent addresses, and then we're going to talk about this new primitive, which is intent addresses. Towards the end, we're going to show you a demo of those in action and what they feel like, and we'll have a bonus round. I'm going to try to keep this kind of interactive and have some time for questions as well. So what's the problem? Problem is something that probably many of you have seen, experienced. Raise your hand if you have used Polymarket before. Nice. Actually, that's a great fraction. All right. Raise your hand if you've ever seen a UI that says something like, send this coin on this chain, anything else might be lost. OK. That should be a superset of that. Perfect. Yes. And it looks something like this. OK, select Polygon, not Polygon, CKM, EVM, or you may lose funds. And it goes to this challenge that, probably many of you have experienced. You've also seen like people talking about it at conferences a lot. Oh, we have roll-up fragmentation. We need chain abstraction. We need things to fix this. This is this nice line from a recent Vitalik article where he's talking about the idea of one Ethereum. But I think what makes us really excited about intent addresses, the thing we're going to talk about today is all like things that work right now. There's a lot of sort of forward-looking fixes for this general problem, from chain-specific addresses to wallets that have bridging built into them. Those things are all nice. We're going to show you something today that lets you fix this problem with existing wallets and even with custodial apps like Lemon or Binance or Coinbase. So very briefly, let's touch on universal accounts and sort of the road that got us here. So there's this idea of, OK, an EOA works on every chain. Something like a Gnosis safe might not by default. If any of you remember the Wintermute hack from 2 years ago, there was that moment where they had a Gnosis safe that was not yet deployed on a new chain, but they received a big transfer to that address, and that ended up poorly. And there's these things that people have been sort of, that broadly, like the Ethereum R&D world has been working to fix this. That center around Create2 and 4337, where you can make a single address that works on every chain. That's sort of what inspired where we're about to go. How many people here have heard of Create2? Nice. Mostly on that side. OK, great. Create2 is a mechanism that lets you commit to a contract on Ethereum. So it lets you create an address that only one specific contract can ever be deployed to that address, and it lets you know what that is ahead of time. And it gives us some really powerful options. So we're going to talk a bit about what we're going to do with that next. So like an intent address lets you accomplish arbitrary actions on Ethereum just by sending funds. And so just like in that case with the universal accounts, where it's like we're going to use Create2 to have the same contract on every chain, and historically people have been mostly thinking about those kinds of things for account abstraction accounts, wallets, things like that. We can actually take that one step further and say, we're going to make something that's very general, where you can actually accomplish any action on Ethereum just by creating an address that's sort of an any-chain address, and you send funds to that address, and it does what you want it to do. And we're going to see in just a bit that lets you achieve some really nice UX as well. So you have a single transfer from, it could be a wallet like MetaMask, it could be a custodial app like Coinbase or Lemon, into an intent address. And then just by sending that, you trigger any number of things. So we have the example earlier of a deposit into Polymarket. We have swapping, bridging. We have arbitrary contract calls. So we're going to take a quick look at what this feels like and how it works. So the first case is the simplest case. It's like, OK, how do you make something happen just by sending to an address? So in this example, we're transferring some USDC into an intent address, and then the contract that we're committing to, the only contract that can be deployed at that create to address, it's constructed in such a way that any relayer can come in permissionlessly and make a specific call. So in this case, for example, like go and mint an NFT and use that funds in the address to pay for that. And so it can only do that one thing. We can take this further, though. So actually, one last thing before we take it further. Just for that, this is already like a big UX benefit. And what it does is, instead of having the flow that you've probably seen a lot of times, where you end up going from a dApp to a wallet twice, once for an approved tokens call, and then once to do whatever it is you want it to do, you can shorten that to one round trip where it's just a transfer. And for things like Coinbase or Binance, it makes it possible to deep link directly into those apps and say, like, hey, open this custodial app, make this transfer, and then just by the user, in both cases, it's an experience that's a bit like Google Pay or Apple Pay or anything like that. They get one pop-up, they say yes, and then after that, it's done. So how does this help this idea of one Ethereum? So we can make intent addresses that let you achieve like a goal on any chain by sending funds from a different chain. How does that work? So in this case, you're transferring funds into the intent address, and the intent address encodes the parameters of the action you're trying to take, including the destination chain. So if you're calling a function on that contract, it knows that you're not on the destination chain yet, and the only thing it will let you do is swap and bridge and send the funds that are in that address into a bridge initiation. So for example, let's say that we had one that is a deposit into Polymarket, but you're paying from Optimism this time. So what you can do there is, say it's a $100 deposit. What this intent address would encode is the relayer can say whatever swaps that they want to do, anything that they want to do with the assets that are in that address. And as long as that produces 100 USDC that go into a CCTP bridge. And then on the other side, on the destination chain, that bridge is going to complete. It's going to land in the intent address, and it's going to and you can call that same. So this is the same intent address, the same contract, but now on the destination chain. It knows it's on the destination chain. It knows block.chain ID, and here it's going to let you do the final action. So this is cool. This is very general. It lets you do sort of chain abstraction with nothing more than a transfer. The only problem with this is it's still slow. You can see CCTP takes about 20 minutes, and so you have this nice any chain, any coin experience, but it takes a while. So we have a mechanism to fix this as well using an escrow contract. So how do we do fast finish? How do we do claim? So same exact action on the source chain, but this time on the destination chain, the relayer is going to go through an escrow contract and say, hey, I'm finishing for this particular intent address. It's going to arrive later in 20 minutes, but I'm just going to do it right now. And the escrow contract is going to mark that relayer as having paid. And then 20 minutes later, when the CCTP arrives, it goes into that same intent address. The intent address is going to forward it to the escrow. The escrow is going to check, hey, did anyone go and fast finish this before? And if they did, then instead of going to the final destination, because that's already happened earlier, it goes to pay back the relayer. So we have this thing that I think is a really elegant sort of construction. And what does it give you? It gives you better UX, it gives you better interoperability, and it gives you something that is permissionless. Let's touch on that last point a little bit. So one way that you can do a very similar user experience that is kind of cheating, you can allow users to just send funds to, say, an EOA that some chain abstraction relayer service controls. And so, in the Polymarket example, hey, send me $100 worth of any token on any chain, and then I'll immediately go and complete the action that you want over here on Polygon, and then I'll just settle out on the back. But this has, regulatory issues. It has, counterparty risk, and you have, a trusted custodian. I think the magic of intent addresses is it lets you accomplish that same exact UX, but non-custodially. And when you're sending funds to an intent address, there's only one specific thing that those can be used for. So let's do the demo. So here's 2 places where we've deployed this. How many people here have heard of small brain games? 1. OK, that's cool. All right. Yeah, small brain games is fantastic. They're a very small game development studio, but they do a lot of really fun sort of inventive experiences on Ethereum. So they made this thing recently called Tomorrow.news that lets you predict tomorrow's New York Times headline. And then people end up getting paid out. It's a prediction market on that in proportion to how close they were. So we built a any chain, any coin deposit into that. So those was contracts on base, but it was something where you could type in a prediction, hit go, and then pay that from any token. Here's the second thing that we did, and I'm going to show this as a video demo. So some of our friends at Ethereum OS, Freedom Factory, they made a new kind of hardware wallet that has some really nice properties, and they did a pre-sale for it, or a pre-order for it, rather. So let's say that you want to pay for this on any, let's say you want to pay for this, but you don't have tokens on base. What does that look like?
Here's a quick demo of intent addresses. So we're going to pre-order a DGen 1, which is a new hardware wallet made by Freedom Factory. If I click any crypto, you can see that we see all of our balances across all chains. Let's pick ETH on Optimism. Ticker is ETH. We'll send that through, and then very shortly after, we should get this payment completed. And if I go here and check out, we can see that it pipelined that transfer through into a Arbitrary contract call over on base. That's all we've got.
Man, that's a weird experience, listening to my voice from the big speaker like that. That's funny. But yeah, you can see that this is very fast. And one other thing, if you were looking closely, you can see that there's only one wallet pop-up. This is actually especially important on mobile, where on desktop at least it's a pop-up, but on mobile it ends up switching you from whatever app you're in over into a wallet app. On iOS you have to switch yourself back. There's no way to do it automatically. Then if you have to do that whole round trip a second time, it gets to be an experience that's just markedly worse than a lot of the Web 2 experiences. And so this fixes that, gets it down to one round trip. Let's talk very briefly about bonus stuff. So we have, intent addresses are gasless over on the destination chain, gasless with whatever you're doing. With permit, we can additionally make them gasless on the source chain. So we can make it so that, for example, if you have just USDC and nothing else, then you can just sign a single message, and the relayer does everything else, and you end up, OK, you placed your Polymarket bet. Once this is a bit more Lindy, once the ideas, so we have this right now, this is like a new and exciting thing, and we just shipped an implementation of it. I think it's a general idea that like people can reuse. And once there's been like enough sort of like mileage on this idea, we have a nice opportunity, I think, to turn this into an ERC that gives you a beautiful progressive UX, where if you have, for example, a wallet that supports this ERC and understands it, it can show you exactly what the intent is doing. Like, oh, actually, you're sending some funds to Ansgar.eth over on Optimism, when what you're doing immediately is actually a transfer here over here on Base. And it has a nice fallback, which is a wallet that doesn't support this yet. We'll just show it as a bare transfer to an address. And lastly, we have this idea of self-destruct. So this is a bit more deeper in the weeds, but if any of you are familiar with the lore and sort of the story of self-destruct, it was a problem opcode for a long time. It had a gas refund at one point that was removed because it caused problems. But at this point, self-destruct has actually been minimized to where it only works within a single transaction. Basically, it's a way that lets you do ephemeral contracts at this point, where you can create a contract, self-destruct it later in that same transaction. And so, as far as we can tell, all of the reasons to not have that gas refund no longer apply. And it'd be really nice to have that refund back because, for things like intent addresses, they're ephemeral. Each intent address represents a single deposit, checkout, action, and then after that it's gone. And so with self-destruct, we can clean up after ourselves and not pollute the state tree. And that's all we've got.